brightness implies that if it represents reflection of sunlight from a solid object, it needs to be 20 kilometers in diameter. That's bigger than Manhattan Island. This is a giant rock. The previous interstellar objects were hundreds of times smaller. So it just doesn't make sense that the third object from interstellar space will be 100 times bigger than the previous two. This object was targeting the inner solar system. It had a goal to visit the inner solar system.
On the 1st of July, NASA detected a mysterious object.
A nuclear-powered spacecraft sent by aliens.
3I Atlas was an interstellar visitor.
NASA has just made an announcement that flips everything we thought we knew about space on its head.
Right now, a fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system.
The strange interstellar visitor known as 3I/ATLAS isn't following the rules of physics we've always relied on. Instead of slingshotting past the sun and back into deep space like every other known object from beyond our solar system, 3I/ATLAS is doing the unthinkable. It's staying. Until now, these objects have always been temporary guests. Oumuamua did it. Every recorded interstellar comet or asteroid has done it. They appear, pass through, and vanish back into the void. But 3I/ATLAS has broken the pattern completely, and no one can explain why. Adding to the mystery, there are credible reports that NASA has quietly suspended operations on the International Space Station. Is this just a precaution tied to 3I/ATLAS? Or is there something much bigger happening behind the scenes? Some suspect national security. Others whisper about a darker truth. Stay with us, because we're about to break down everything NASA isn't telling you, and what it could mean for the future of life in our solar system. NASA's announcement, couched in technical language and cautious phrasing, essentially confirms what many researchers have been reluctant to say out loud. This is no longer behaving like a comet. It's something that has effectively parked itself in our neighbourhood of space, and it's not leaving. If you want to stay on top of what happens next with 3I/ATLAS, hit that subscribe button and turn on notifications, because this story is only getting started. The announcement came during what was supposed to be a routine orbital mechanics briefing. A senior NASA astrophysicist stood before reporters and delivered news that fundamentally changes how humanity relates to the cosmos. After 3 months of non-stop tracking, NASA now confirms that 3I/ATLAS has achieved a stable orbit around our Sun. Its current trajectory forms a highly elliptical path with a period of about 127 years, which places it permanently within our solar system. The room went dead silent. Then the questions began. How could this even happen? What process could make an interstellar object slow down enough to be captured? Has anything like this ever been seen before? NASA's answers were measured. They're still studying the data to determine the exact mechanism. Several theoretical possibilities are being explored. They called it a once-in-a-lifetime chance to study an extrasolar object long-term. But what they didn't say spoke louder than what they did. No mention of propulsion. No discussion of the impossible energy requirements. No acknowledgement that every orbital model says this can't happen naturally. One senior astronomer who was present described the mood in the room. Everyone understood the implications. This wasn't a simple update. It was NASA, in the most careful way possible, telling us something artificial has just taken up residence in our solar system. The technical language was a diplomatic cover for a reality no one was ready to accept. The orbital data NASA released tells its own story. 3I/ATLAS's new orbit carries it from just inside Earth's orbital path out to the asteroid belt before looping back again. At its closest approach, it will come within 15 million miles of Earth, close enough for detailed study even with smaller telescopes. At its farthest, it swings past Mars before returning inward. That's not some random capture orbit. That's a path that allows optimal observation of the inner solar system while staying far enough from the Sun to avoid severe radiation. To understand why NASA's announcement is so shocking, you have to understand the physics behind what happened. Interstellar objects enter the solar system with what's called hyperbolic excess velocity. They're moving so fast, the Sun's gravity can't capture them. Think of it like throwing a ball. Throw it hard enough and it escapes Earth's gravity completely. That's what hyperbolic velocity means. Oumuamua entered at about 87,000 miles per hour. It slingshotted around the Sun, gained speed from the assist, and then sped out into interstellar space at nearly 200,000 miles per hour. That's the normal pattern. Atlas entered at roughly 130,000 miles per hour. To get captured, to slow enough for the Sun to hold it permanently, it had to lose about 70,000 miles per hour of speed. That's an extraordinary amount of energy to shed. A JPL orbital mechanics expert described how impossible this is. To lose that much speed naturally, 3I/ATLAS would have needed to collide with something massive, which would destroy it, or perform multiple perfect gravitational assists with planets in a precise sequence. We've mapped its path. It didn't do any of that. Instead, it slowed continuously over several months, something that would require steady thrust. No natural process can do that. The deceleration pattern NASA recorded makes it even stranger. Instead of a smooth slowdown, 3I/ATLAS reduced speed in distinct steps, periods of active deceleration followed by coasting phases. That's exactly what you'd expect from a spacecraft with limited fuel, burning its engines in bursts to conserve resources. Natural objects don't carry fuel. They don't manage their deceleration in optimal patterns. And they certainly don't perform precision maneuvers that result in a stable orbit on the first attempt. A propulsion engineer who analysed the data calculated what would be needed for 3I/ATLAS to achieve this. It would require a propulsion system capable of running for months, carrying fuel equal to about 40% of the object's total mass. That's technology decades beyond what we currently have, and that's assuming it's using conventional engines. If it's powered by something more advanced, ion drives, nuclear propulsion, or physics we haven't discovered, the implications are even more extraordinary. The Orbit 3, I/ATLAS follows, isn't random. When you examine its parameters, the inclination, eccentricity, and the perihelion and aphelion distances, a distinct pattern appears. This path was selected for deliberate strategic reasons. With an orbital period of 127 years, 3I/ATLAS completes one full circuit roughly twice in the average human lifetime. That's long enough to observe several generations of human progress, but short enough to return regularly for updated intelligence. Its orbital inclination is nearly zero, meaning it travels in the same plane as Earth and the other inner planets. This is the ideal configuration for observing planetary activity. An inclined orbit would place it above or below the ecliptic plane for long periods, reducing observation angles. 3I/ATLAS sits in the perfect surveillance zone. A military space analyst explained what this means. If I were assigning a reconnaissance satellite to monitor the inner solar system, this is exactly the orbit I'd pick, they said. Close flybys of Earth for detailed observation, extended time in the asteroid belt to remain difficult to track, and a trajectory offering line of sight to every inner planet at various points in its cycle. Atlas's perihelion, its closest point to the Sun, is just outside Earth's orbit. That position is strategic for two reasons. First, it avoids the intense solar heating that destroys natural comets. Second, it allows regular close approaches to Earth without the object ever entering the planet's Hill sphere, where gravity could take over and capture it. But here's where things get even more unsettling. NASA's data shows the orbit includes regular alignment windows with Earth. Every 11 years, 3I/ATLAS returns to nearly the same position relative to our planet. That's no short-term coincidence. It's built-in resonance, designed to ensure consistent observation opportunities for centuries. An orbital dynamics researcher projected its future positions. Over the next several hundred years, 3I/ATLAS will pass through specific zones aligning predictably with Earth's position. For anyone planning long-term surveillance, the geometry couldn't be better. 3I/ATLAS can get a close look at Earth roughly once per decade indefinitely. The orbit also gives it flexible options for course correction. If 3I/ATLAS wanted to shift its path, move closer to Earth, or adjust its timing, the orbital mechanics make that possible with minimal energy. It's not trapped in its current trajectory. It has positioned itself for maximum adaptability. As astronomers combed through decades of sky survey records, a troubling pattern emerged. 3I/ATLAS may not be the first interstellar object to establish a permanent orbit within our solar system. We simply failed to notice. A research team analysing 40 years of archived observations found 17 objects with unusual orbits that don't fit the profiles of normal asteroids or comets. Their parameters suggest they came from outside the solar system, but now circle the Sun in stable, long-term orbits. Most of these objects are small, between 50 and 200 meters across, making them hard to detect and track consistently. They were categorized as unusual asteroids and largely ignored because they posed no collision threat to Earth. But now, in light of 3I/ATLAS, scientists are re-examining them. And the more they study these objects, the less they resemble natural captures, and the more they resemble a network of surveillance stations operating around the Sun for decades. A planetary scientist reviewing the data put it this way: "We've been assuming any interstellar visitor would behave like Oumuamua, swing through and leave. 3I/ATLAS broke that assumption. Now we're realizing there may be dozens of objects that have done exactly what 3I/ATLAS has. We just didn't recognize it at the time." Some of these objects share 3I/ATLAS's impossible traits: slight but measurable course corrections, electromagnetic emissions at regular intervals, and orbits optimized for observing the inner solar system. One example, designated 2003 QX113, has followed a highly elliptical orbit for more than 20 years. Its path brings it close to Earth every 7 years. Close enough for detailed observation, but not close enough to draw public attention or trigger defensive measures. Its composition matches 3I/ATLAS's: high metallic content, including the same unexplainable titanium-vanadium alloy. Another, 2011 KT-19, holds an orbit that keeps it positioned between Earth and Mars most of the time. A perfect relay point for communications between objects near Earth and something farther out in the solar system. What few people realize is that we may have been under observation for decades without knowing it. The solar system might already be filled with monitoring stations from civilizations that discovered us long before we discovered them. NASA's announcement has split the scientific community into opposing camps. The debate isn't about whether something unusual is happening. The data is clear. The real argument is about what it means and how to respond. One camp, led by established astronomers, insists we're seeing exotic natural phenomena we don't yet understand. Maybe 3I/ATLAS is surrounded by a swarm of smaller objects whose combined gravity slows it down. Maybe it's venting gases in patterns we can't observe, producing thrust like a natural rocket effect. Maybe there are mechanisms in astrophysics still undiscovered. A leading astrophysicist summed up this view: "Extraordinary claims require extraordinary evidence." Yes, 3I/ATLAS's behavior is odd, they argue, but jumping to the conclusion that it's artificial is premature. Nature has surprised us before. It will again. We can't throw out scientific rigor just because something doesn't fit our models. The opposing faction counters that refusing to see the obvious is itself unscientific. When every natural explanation demands multiple unlikely coincidences or undiscovered physics, the simplest answer may be the right one. 3. I/ATLAS is artificial. A Harvard astrophysicist has been especially outspoken, asking, at what point do we acknowledge what the data is telling us? We're looking at an object that changed its orbit through sustained deceleration, broadcast mathematical signals, contains impossible material compositions, and placed itself in a near-perfect surveillance path. If this were a satellite built by Russia or China, no one would hesitate to call it what it is. The only reason for debate is that accepting the obvious forces us to rethink everything we believe about our place in the universe. The debate has turned deeply personal. One side accuses the other of sensationalism, while the other responds with claims of willful blindness. Conferences have become confrontational, and research papers are being rejected, not based on quality, but on whether they align with the accepted interpretation. A science journalist covering the issue described the situation bluntly. This isn't a scientific discussion anymore, it's ideological warfare. Both camps are so entrenched that no amount of evidence will change anyone's mind. The establishment refuses to consider the possibility that it might be wrong about something so fundamental, while the challengers can't back down without losing credibility. As a result, we're at a complete standstill while 3I/ATLAS remains in our solar system, continuing whatever it's doing. Meanwhile, the public is watching scientists argue as the implications grow heavier. Social media is filled with theories, some rational, others entirely fantastical. Religious figures are struggling with what this could mean theologically, and governments are quietly preparing for possibilities they once thought were impossible. While experts continue to argue over data and interpretations, 3I/ATLAS itself keeps operating in its new, stable orbit, and its actions make it clear that it's not just passively drifting through space. Radio telescopes tracking the object have reported changes in its electromagnetic emissions since it settled into orbit. Instead of the mathematical sequences it broadcasted during its approach, 3I/ATLAS is now sending what seem to be status reports, structured bursts of data every 6 hours. Each burst carries dense, complex packets of information. A SETI researcher studying the transmission summarized it this way: the timing is too exact to be natural, and the information content is far too structured to be random. Something is transmitting operational data on a strict schedule. Whether those packets contain diagnostics, observation logs, or something else entirely remains unknown, but they clearly represent intelligent communication. Visual tracking adds to the mystery. Since achieving orbit, 3I/ATLAS has released several smaller objects. Amateur astronomers have documented at least 30 of them, each separating from the main body and arranging themselves around it in geometric formations. These smaller units maintain precise distances from one another, forming what looks like a three-dimensional sensor array. When one moves, the rest adjust to preserve the exact spacing. This is coordinated behavior that would require either distributed intelligence or centralized control. Thermal imaging has also revealed something that natural bodies don't show. 3I/ATLAS is producing more heat than it receives from the sun. That means it's generating internal energy, possibly from radioactive decay, fusion, or another unknown source. Natural comets and asteroids don't have built-in power generation systems. the heat isn't spread evenly either. It's concentrated in distinct areas, suggesting specialized zones within the structure, perhaps engines, living quarters, or systems we can't yet identify. A thermodynamics expert studying the readings explained, the heat distribution looks artificial. Natural objects have fairly uniform temperatures determined by sunlight and composition. 3I/ATLAS has clear hot and cold regions arranged in patterns that indicate deliberate control. Someone or something is managing its thermal output. Recent data shows 3I/ATLAS has also begun rotating. It's not tumbling like a rock in space, it's spinning smoothly on a fixed axis. The rotation rate is roughly once every 32 minutes, generating artificial gravity of about 0.3 g at the surface. That's enough to make movement easier than in zero gravity, but gentle enough not to stress a lightweight structure. This rotation wasn't present during 3I/ATLAS's approach. It began only after it established orbit, implying a specific function. It could be maintaining habitability for biological occupants who need some gravity, or it might serve engineering purposes like temperature, regulation, or communication stability. Whatever the reason, it's yet another sign of purposeful activity. Atlas's long-term presence in our solar system has set off a wave of geopolitical consequences that no one was prepared for. The biggest question now is, who, if anyone, has authority over it? The answer isn't clear, and that uncertainty is already causing international tension. The 1967 Outer Space Treaty declared that no nation can claim sovereignty over celestial bodies. But that agreement was written with moons and asteroids in mind, not an artificial structure from another civilization. So now, the world faces new, urgent questions. Does 3I/ATLAS belong to its creators? Does it belong to humanity as a whole? Can individual countries communicate with it, or act against it, without a global consensus? These aren't theoretical issues anymore. They're immediate legal and diplomatic problems with no precedent. The United States has claimed observational priority because NASA first tracked 3I/ATLAS. China insists that space belongs equally to all nations. Russia argues that 3I/ATLAS should be considered a potential threat until proven otherwise, justifying defensive preparations. Meanwhile, the European Union is calling for a UN-led international response committee. One international law expert summed up the chaos. We don't have a legal framework for this. Every nation is acting according to their own reading of treaties that were never meant for this situation. It's a setup for serious misjudgments. If any one nation takes independent action, whether trying to communicate with 3I/ATLAS or worse, attacking it, there's no system in place to hold them accountable or to prevent escalation. Military strategists are particularly alarmed about the potential weapons implications. If 3I/ATLAS contains technology far beyond our own, the country that gains access first could achieve overwhelming military dominance. That possibility creates strong incentives for rash or aggressive behaviour, even among allies. Intelligence reports already indicate that several nations are developing plans to send missions to 3I/ATLAS.